skip it because I don't have time to do all of them, but it is E. I just wanted to do at least one of each type of problem. On that one, you can factor out the GCF, and what's left is a difference of squares. On number 6, since we start with 4 terms, first we want to look and see, can we factor out a GCF from each of them? But since I can't factor out a GCF from each of them, we're going to factor by grouping, right? Which is our final step on problems like number 4. Okay, so I've got x cubed plus 6x squared. What can I factor out of both of those? Is I can take an x squared out of both of those. That leaves me with x plus 6 inside the parentheses. Okay, and then in 3x plus 18, I can't take an x, but I could take 3 from both of those, okay, and a positive 3. So that leaves me with x plus 6 in here too. 18 divided by 3 is 6. Right, what's inside the parentheses should be the same. So x squared plus 3 and x plus 6 should be my 2 factors for this one. Right, x squared plus 3 and x plus 6. G. You're going to do the same thing on number 7. You can factor by grouping. I'm not going to go all the way through that one again because we don't have that much time, but I will tell you that you'll get answer choice H on that one. Okay, number 7, you'll get H if you do it the same way as we did on number 6. And also on number 8. Okay, it's another one where you want to factor by grouping. There's 4 terms. You can factor it by grouping, and this one you'll get answer choice J. Number 9, I want to go over together. Okay, it's got 2 terms. It's a difference, but it's not a cube. Okay, because 9's not a cube, 4 is not a cube, to the 4th power 36 is not a cube. Okay, in this case, when we have numbers this big, we want to first try to factor out our GCF. Okay, well, what goes into 9 and 36? 9. Okay, that leaves me with x to the 4th power minus 4. We're at 9 times x to the 4th power minus 4. So my greatest common factor is 9, x to the 4th power minus 4. Okay, now this one is actually a difference of squares. Okay, a difference of squares. We've talked about how if it's a difference of squares, if b in the middle is 0. Okay, so this was really x to the 4th power plus 0x minus 4. Right, and we also talked about, okay, well, even though it's to the 4th power, well, that's x squared times x squared, right? 2 plus 2 is 4. Okay, so that's a squared. It's going to have 2 x squareds in it. 4 is a square number. And we talked about if you did a times c, 1 times 4, you'd have negative 4 here. And you need it to add up to 0. Okay, well, what do they have to be to add up to 0? They have to be the same number. Okay, 4 is a square number. What's the square root? Is 2 and negative 2. Okay, so it would be x squared plus 2 and x squared minus 2. Okay, and I'm going to bring down my GCF of 9. So it's 9 times x squared plus 2 times x squared minus 2. Okay, the only thing different about this that we haven't seen before is that it was x to the 4th power, but that's still a squared. Okay, and you can still do it the same way. Okay, and that was answer choice B. Now number 10, you just need to factor out the GCF. Okay, that would give you answer choice K. Number 11, it would be kind of like we did here, right? You needed to factor A times C and get your 2 factors and break this apart. The answer will be A. Right? And number 12, this is a sum of 2 cubes again. Okay, and that would be answer choice F. Okay, I just want to give you those so that you can know if you went in the right direction on those. Number 13 and 14, I'm not going to go through those. It says evaluate the function for the given value of x. Okay, there's a couple different ways you can do that. You can plug in -6 where all the x's are and see what you get. Okay, also we learn how to do it using synthetic division. With synthetic division, your remainder is your answer. Okay, so that's how you would do those. I think people kind of understand that. Let's do number 16, okay? Number 16, just because I think end behavior was something that people had questions about, right? This would be like on our 4.1 notes, number 6 and number 7, okay? They want you to tell the end behavior. They give you a polynomial and they want you to tell them the end behavior. Okay, first we need to find the degree. Okay, the degree, this one is not in standard form, right? To put it in standard form, I'll go ahead and do that, even though they don't ask us to, but that makes it easier. The highest exponent needs to be first. So it'll be -6x to the 7th power. The next highest would be -14x to the 4th power, then plus 10x squared, minus 14x, minus 11. Okay, the degree is the highest degree that you see. So the degree will be 7. I'm not asking you the type because we didn't talk about the names of the anything to the 7th degree. We just talked about the first 4. So the degree is 7, and then we wanted the lead coefficient, which I abbreviated LC in our notes. Okay, the lead coefficient, which would be, they have it written out here. Okay, it's just the very first number in front of the highest degree. So it's negative on this one, okay, negative. Okay, so the degree is 7, which is odd, right? It's an odd negative problem, okay? So we know it's odd, we know it's negative. Remember, negative means that the ends are going to end up going this way, okay? It's going to look like this. So it's going to go 1, 2, 3, 4, 5, 6, 7, okay, is what it would look like. Okay, but what you need to know is, on the left-hand side, it's going to positive infinity, right? On the right-hand side, because it's going up. Okay, on the right-hand side, it's going to negative infinity because it's going down. That's what they're asking. Okay, remember on the left-hand side, it would say f of x, the graph, goes to positive infinity as x goes to negative infinity. That means on the left, this means graph goes up on the left, and then it's going down, so it will be f of x goes to negative infinity, right, down, as x goes to positive infinity, to the right, okay? The graph goes down on the right. And I could just